In this video, I'll be discussing Program 10, which is a basic program for calculating yearly pay. However, first I want to quickly discuss a few less popular data types. In the previous videos, I discussed the 5 popular data types in Java, which are string, int, double, char, and boolean. In this video, I will quickly discuss 4 additional, less popular data types in Java, which are byte, short, long, and float. All 4 of these data types are used for storing numbers, which is why they are less popular, because typically everyone uses int or double. The definition of 1 bit is 0 or 1, and 8 bits is 1 byte. And so that's how we end up with the data type byte. And a byte can store integers from negative 128 to positive 127. So when would the byte data type be used? In cases such as days in a month, you can store 30, hours in a day, 24, and days in a week, 7. In all these cases, the number is between negative 128 and positive 127. An integer uses 4 bytes, so by using the byte data type instead of int, you can save on memory in these situations. However, if trying to store a number outside of this range into a byte, the compiler will give you an error. And if we look at this error, it says mismatch cannot convert from int to byte. So Eclipse understands that the range for the byte data type is between a negative 128 and positive 127. A quick explanation how these number ranges are determined. So as I previously stated, the definition of 1 bit is 0 or 1, and the total possible numbers that can be stored in 1 bit ranges from 0 to 1, obviously. With 2 bits, you can have 4 possibilities, which I've shown here, 0, 0, 0, 1, 1, 0, or 1, 1. With 3 bits, you can have 8 total possibilities, which I've shown here. And you'll notice if I take the 4 possibilities from 2 bits, and I add 0 in front, and then add a 1 in front, that'll give me my total 8 possibilities. And I can continue this pattern with 4 bits, which is 16 possibilities. Take the 8 possibilities from 3 bits, add zeros in front, and then the same 8 possibilities and add 1 in front to get a total of 16 possibilities. So you'll see the pattern over here is 2 raised to the number of bits power. And so for 4 bits, I have 2 to the 4th, which is 2 times 2 times 2 times 2, which is 16 total possibilities. And so with 16 total possibilities, I can store numbers from 1 to 16 or 0 to 15. However, if I want to store negative numbers, I can use the first bit for setting as negative or positive, and then I'll have 3 bits remaining for the actual number. So with 4 bits, if I use this first bit for specifying negative or positive, then I'll have the remaining 3 bits 8 combinations for the actual number. And so in that case, I'll be able to go from negative 8 through positive 7. And it's not positive 8 because you have to account for 0. So the general formula is the range of numbers possible is negative 2 to the number of bits minus 1 power through positive 2 to the number of bits minus 1 power minus 1 to account for 0. So the next less popular data type to discuss is short. And short uses 2 bytes or 16 bits of memory. So based on the formula I just showed, this is negative 2 to the 15th power through positive 2 to the 15th power minus 1. So if I use the built-in Java functionality math.pow to take 2 to the power of 15 and then I output this, we can see that the range is negative 32,768 to positive 32,767. Right, you should have the minus 1 to account for 0. So when would we use short? If you have a number that's too big for byte, but you want to save memory because you don't need to store it in an int. So here are some examples. Days per year, 365. Minutes per day, 1,440. And seconds per hour, 3,600. So using short in these examples instead of int uses only half as much memory. So the next data type I want to discuss is long, which uses 8 bytes, which is 64 bits of memory. And so the range is quite large, negative 9 quintillion to positive 9 quintillion. The range for an integer is negative 2.1 billion to positive 2.1 billion. And so in cases where you need a range larger than 2.1 billion, that's when you'd use long. So for example, with the world population now over 8 billion, that'd be too large to store in an int. So you'd have to use long. Another example is here, there's a built-in method, system current time millis, which is the number of milliseconds that have occurred since midnight, January 1st, 1970. And so if I run this, we can actually see how long that is. And so this is the number of milliseconds that have occurred since January 1st, 1970. This is usually called epoch time, January 1st, 1970. And then this is the actual max. And so there's actually a built-in capability to Java where you can type in long.max value. You can do integer max value as well to get the max value for integer. But you can see it's the 9 quintillion as I've shown up here. So now let's do a little experiment. So I have var, which is an integer, and I placed 2 billion here. I've taken var times by 2, and I should end up with 4 billion. But as I've just stated, 4 billion is too large for an int. So we'll look and see what happens when I do that. Down here I can do long with 2 billion, and then I can take that 2 billion times by 2, and we'll see what the difference is. So when I run this, you'll see when I did the integer and it went outside of the range, I ended up with some crazy negative number. But when I used long, which 4 billion is still within the range, you can see it actually was the correct answer of 4 billion. So when running a program, it might look like it's going to work correctly, but when it actually runs, it could end up being outside the range and giving you a wrong number. One additional thing I'd like to discuss is when you plug in a value that is quite large, for example this. You'll notice this should fit the range, but you can see Java assumes that it's an int. So when dealing with a long, in order for this to work and compile, you have to put an L on the end. So either uppercase L or lowercase l. I don't usually like to use lowercase l because it looks like a 1. So a lot of times I'll use uppercase L. And so in this case, this will compile correctly. And if I run it, it'll work. The last data type I'd like to discuss is float. And so float is similar to double. So double uses 8 bytes, and Java assumes all decimal values are of type double. And so float, if you want to save on memory, only uses 4 bytes. Most programs could use float instead of a double, but double is typically more popular because, and here are the reasons, being concerned with memory usage isn't as big of an issue anymore. And number 2, when assigning values to a float variable, you need to add f to the end. With float, in all cases, Java assumes it's always a double. So in this case, you always have to add an f to the end if you want to put it as a float value. Now let's look at the instructions for program 10. The title is yearly pay, and the objective is, suppose an employee gets paid every 2 weeks and earns $1,750.25 each pay period. In a year, the employee gets paid 26 times. Write a program that defines the following variables. Pay amount. This variable will hold the amount of pay the employee earns each pay period. Initialize the variable with 1,750.25. Pay periods. This variable will hold the number of pay periods in a year. Initialize the variable with 26. Yearly pay. This variable will hold the employee's total yearly pay, which will need to be calculated using the above variables. The program should calculate the employee's total yearly pay by multiplying the employee's pay amount by the number of pay periods in a year, and store the result in the yearly pay variable. Display the total yearly pay on the screen in the following way. An employee earning $1,750.25 for 26 periods will earn $45,506.50 each year. As always, to begin working on this program, first create a new workspace for program 10 by following the instructions in my video with the title Create a New Programming Project, or watching the solution to program 2. To view additional materials and the solution code for this program, visit the Java in a Jiffy website at www.javainajiffy.com/programs/10. Once you have completed this program, watch my solution video where I discuss the solutions code and highlight any important concepts and techniques. If you found this video helpful, please click the like button. To help support this channel, please click the subscribe button. Thanks for watching.